In this video, we're going to look at compound interest. In the first example, it asks, what is the future value if $3,200 is invested for 5 years at 8% compounded quarterly? So let's take a look at the formula and talk about each variable and what it represents, and then we'll get started on the problem. So we have A is equal to P times 1 plus R over M raised to the MT. So A is your accumulated value. So this is the money that you invested and the interest made. P is the principal amount, so your initial investment. R is your nominal rate. M is how many times it's compounded per year. And then T is in time for years. So in this problem, we want to find future value, so we want to find A. So A is equal to our principal amount, which was $3,200, times 1 plus our rate divided by our compound. And our rate is 0.08 for 8%, divided by, we're compounded quarterly, so our M is equal to 4. And we invested it for 5 years, so we have 4 times 5. So now let's simplify all this. We have 3,200 and 0.08 divided by 4 is 0.02, so we have 1.02, and 4 times 5 is 20. So now we can calculate with our calculator, and when we do that, we get 4755.03, and remember, that's dollars. So if we invest $3,200 for 5 years at 8% compounded quarterly, we would have $4755.03. In the second example, the question asks, what present value amounts to $10,000 if it is invested for 10 years at 6% compounded annually? So now it's asking us for a present value or a principal amount. So we know A is 10,000 equals to, now we're looking for P, and we know that we have 1 plus our rate, which is 6%, 0.06, divided by compounds, and it's compounded annually, so this is 1, raised to the MT, and M was 1 times T is 10. So we have 10,000 is equal to P times 1.06 raised to the 10th, and then P is equal to 10,000 divided by 1.06 raised to the 10th. So our principal amount was equal to $5,583.47. So we have to invest $5,583.47 at 6% compounded annually for 10 years in order to have $10,000 in our account. In this next example, we have at what nominal rate, compounded quarterly, would $20,000 have to be invested to amount to $26,425.82 in 7 years. So here we're trying to find R. So we know A is equal to 26,425.82, and that's equal to P, which is 20,000, times 1 plus R, because that's what we're trying to solve for, divided by 4, because we're compounded quarterly, raised to the MT, which is 4, and time was 7 years. So we're going to divide both sides by 20,000, and we get 1.321 is equal to 1 plus R over 4 raised to the 28. And now I'm going to raise both sides to 1 over 28. So I have 1.321 to the 1 over 28 is equal to 1 plus R over 4. and we get 1.01 is equal to 1 plus r over 4, and now we subtract 1 from both sides, and we get 0.01 is equal to r over 4, and then multiply both sides by 4, and we get r is equal to 0.04, or 4%. So the nominal rate is 4%. If we compound quarterly and we invested $20,000 for 7 years, we would have $26,425.82. In this last example, we have how long in years would $700 have to be invested at 11.9% compounded continuously to earn $300. Now this formula is a little bit different for compounded continuously. We have A is equal to principal times E raised to the RT. So now our A is equal to our accumulated, and we started with $700 and we earned $300 in interest. So we have $1,000 for our A is equal to our principal, which was the amount we invested, $700, E to the RT, and we're trying to solve for time, so we're going to have 0.119t. And the first thing I'm going to do is divide both sides by 700. So I have 10 divided by 7 is equal to e to the 0.119t. And now I'm going to ln both sides. So I have ln of 10 divided by 7 is equal to 0.119t. And then t is equal to the ln of 10 divided by 7 divided by 0.119, and when we calculate this, we find that t is equal to 3 years. So it takes 3 years with an investment of $700 at 11.9% compounded continuously to earn $300 in interest. And that's our video on compound interest.